Welcome back, geometry students. Mrs. Fellon here. We are actually on kind of our third video, our third section of quadratics. And I'm going to go over today just vertex form and factored form and go through a couple examples of how to find kind of all of the information. So at the end of this, you should be able to factor, or you should be able to graph and find all of kind of the important information regardless of what format your equation is in, whether it's in standard form, vertex form, or factored form. And so by important information, I mean like your vertex, your axis of symmetry, your min or your max, your Y-intercepts, and of course your X-intercepts. So we're gonna kind of get through all of those today with the factored form and the vertex form. So we're gonna start with vertex form. So vertex form. There's our vertex form. It is y equals a x minus h squared plus k. So notice that it's still quadratic. And so what makes it quadratic is the fact that you still have kind of this squared term in there. And so that's, I guess, the important part. And so what we're going to be doing now is we're going to kind of looking at like what all these different letters play a part in our overall graph. So first of all, this a value. This controls if it's a vertical stretch or a vertical shrink, right? So if the absolute value of A, so we're not, again, kind of not looking at the sign, is greater than 1, this equals a vertical stretch. If the absolute value of A is less than 1, this equals a vertical shrink. Whoops, R-I-N-K. All right, so in other words, a vertical stretch makes your parabola kind of skinnier, and a vertical shrink makes your parabola wider. And so those are kind of the words I kind of remember. In addition, a positive value, so a positive A, is kind of like it opens up, we'll say. In other words, the graph is pointing up, the parabola is pointing up. A negative A opens down, which then what that does is causes a reflection. We call that a reflection over the x-axis. So again, all this is kind of review from what we did with standard form, right? But same idea. This k value, that's the one on the outside of your graph. So this is that plus, like you might be adding 5 to your overall function or subtracting 2. This controls up and down. So plus k means you're moving up vertically, so like on the y-axis, that number of spaces. Minus k means you're moving down that number of spaces on the y-axis. And then most importantly here is this h value. And so what we're going to talk about here is how to figure out how to identify left and right. So we're going to use the same kind of process that we did when we did circles, right? So I kind of threw that into you, threw that at you before with the h and the k. So if you have an x minus h, okay, that actually means your h value is positive because what you're substituting in there is positive. So this is going to be moving to the right that number of spaces. So if it was x minus 5, it means I'm going to shift from the origin, I'm going to shift to the right 5. If I had x plus h, so because my original equation has the negative in here, if it has x plus h, that is actually a shift to the left. So let's say it was x plus 5. That would mean I'm shifting my graph left 5. Okay, so basically these are all kind of the pieces of our graph. And so what we're going to use all that information to help us figure out our vertex, which we call this vertex form because the vertex is the easiest thing to find. It is simply your h value, comma your k value. And so kind of like what we did with circles, when you're looking at this, it's almost like you're taking the opposite. So if it says like x minus 3, your h value is 3. Because again, it's just the h value that you're looking at, not the minus sign in front. And then the k value kind of stays as is. We're going to look at our axis of symmetry. And so just remember, your axis of symmetry is always x equals the x value of your vertex. So if our vertex is h, the x value is h, then it's x equals h. You're also going to find min and max, and again, that's the same way as we did in the last one with standard form. Depends if your parabola opens up or down. So remember this whole plus a or minus a. If it opens up, this is going to have a minimum. If it opens down, it would have a maximum, right? So think about what the shape of the graph would be. So you would state which one, And then remember, you would state the value on the y-axis. So that would be your k value. So if this were the vertex of 110, then the max, let's say it opens down, the max would be at 10. The other thing you're going to find is a y-intercept. Now, in this format, in standard form, it was easy. It was just like your constant term, right? That number at the end, the c value. In vertex form, it's not your k value. So you have to actually do this algebraically. So to find this algebraically, what you need to do is plug 0 in for x. And to be honest with you, that's always how you find a y-intercept. And so there's other like little shortcut ways around, but that's really algebraically, that's how you find a y-intercept for any function. You plug 0 in for x, solve for y. And then I'm going to show you how to find x-intercepts, and I put that in parentheses because there could be more than one. And so how we're going to do that, and I'll give you some examples. We're going to plug 0 in for y. So a y-intercept, you plug 0 in for x. An x-intercept, you plug 0 in for y. All right, so that's kind of the overall gist of vertex form. Let's do some examples. So let's start by just kind of finding the vertex. So in my example here, we're going to start by looking at y equals 3x minus 4 squared minus 10. So what I want us to do is find the vertex of our graph. So remember the format of your equation. It always goes x minus your h value. So in our scenario here, what number I plug in here for h has to give me, what I have here in the parentheses. Your k value, that's this up here, is going to be this number being added or subtracted to the entire thing that's being squared. So like whatever's being added or subtracted to the squared part of your equation. So in my example here, my vertex would be 4, comma, negative 10. And then once we know the vertex, we actually know a lot of stuff, and we'll get to that in a minute. Like we know the axis symmetry, the min and max, and we can find a bunch of other information. All right, let's do another one. All right, so let's say I had this scenario, same deal. I'm thinking about the original equation, the format, it goes x minus h. So in this case, what number would I have to plug in here in order for this to be x, to turn to x plus 6? Well, my vertex then would have, this h value would have to be negative 6, and then this k value is 9. So again, kind of the shortcut ways people look at this and they say, oh, it's just the opposite of this number, comma, this number, which I guess that works. But again, what I want you to understand, it's not, what it means here is h is positive and h is negative here. All right, let's do some examples. So let's kind of put all of this together and let's find all of this information for one particular function. So I'm going to give you y equals x minus 1 squared minus 4. So what I would have you do, what I'm going to have you do in class, is kind of find all of the important information. So let's start with the vertex, since that's the easiest thing to find. So it's your h, comma, your k. So the opposite of this, which is 1, and then negative 4. Once you know your vertex, your axis symmetry is already here. Just remember to write it as a line. So it's x equals. It's not a number, it's not a point, it's x equals. You would have to determine whether this has a min or a max. And so remember what I said up here. If the parabola opens up, there's a min. If it opens down, it's a max. And so this one, since the a value is positive, like the a value is actually 1 here, it would have a minimum. So you would say a minimum at, and then whatever the k value or the y value of your vertex is. So it's a minimum at negative 4. All right, we have to do a little work here to figure out the y-intercept. So let me show you how to do that. So for the y-intercept, you plug 0 in for x. So that's literally what we're doing, plug 0 in for x. So I get negative 1 squared, which is 1, minus 4, which is negative 3. Always write your y-intercept as a point. And so the point is x has to be 0, because you're plugging 0 in for x, and y is negative 3. All right, let's do the x-intercepts. So to find your x-intercepts, you plug 0 in for y. So let's plug 0 in for y. And now I have x minus 1 squared minus 4. So in vertex form, What I don't want you to do is I don't want you to expand this out. It's just unnecessary work. It's not going to be that it's wrong if you do it that way. I just don't want you to do it that way. So what I'd rather you do is we call this the square root method, which basically just means we're going to isolate or get the x minus 1 squared by itself. So I'm going to add 4 to both sides here. So now that this is by itself, there's no number in front, everything else, now I can square root both sides to get rid of the squared. Don't forget that you have to put the plus and minus here, right? Because there's 2 answers here. And so then what you're left with is x minus 1 on the right side. So now what you're going to do is you're going to add 1 to both sides. So you get plus or minus 2 plus 1 equals x. Okay, that looks a little weird, right? So what we're going to do is we're going to write this as 2 separate points. So you're going to do positive 2 plus 1, which is 3, negative 2 plus 1, which is negative 1. So those are our solutions. To write them as x-intercepts, all we would do is write them as a point. So it's 3 comma 0 and negative 1 comma 0. Again, write them as a point. All right, let's do a little kind of mini graph on this one. We're just going to do a sketch, okay? So on this one, I'm just going to plot everything I know. So I have a vertex right here, 1, negative 4. I have an axis of symmetry, which is that vertical line right through the vertex. The minimum at negative 4, you don't really have to do much with. 0, negative 3 is my y-intercept, and you can reflect that point over your axis of symmetry and get another point. And then your x-intercepts are negative 1, and this is 1, 2, and 3. So now that you have all these points, let's go ahead and sketch our graph. Make sure it looks like a parabola, like in other words, it's rounded, not a V shape. It should be a nice smooth curve. And so that's what it would look like. Let's do one more example. All right, so in example 2, I'm going to give you one a little bit different. So we're going to do negative 1/2 times x plus 3 squared plus 8. All right, start with the basics, right? So let's find the vertex first. So it's this value, your h value, and your k value. So this would be negative 3, 8. So the opposite of this, comma 8. Axis of symmetry, x equals the x value of your vertex. Because this is going to open down because of the negative, so your parabola is going to face down. This would be a max at 8. So again, the y value. Y-intercept. So let's plug 0. Let's do our math here. Let's plug 0 in for x. So one of the ways you could do this with function notation, which is just the p of x here, is basically you're just replacing x with 0. If it makes more sense for you to call p of x y, I don't really care. All right, so 3 squared is 9. So this would be negative 4.5 plus 8, which gives me 3.5. Okay? It doesn't always have to be integer values, right? In most cases, it's not. All right, x-intercepts. So our game plan here is to plug 0 in for y, or in this case, p of x. Remember what I said, do not expand this out. Isolate whatever's being squared. So I'm going to subtract 8 from both sides. It's like you're solving for this. You're solving for x plus 3 squared. So get rid of the negative 1/2. So you're going to multiply both sides by negative 2. So what do I get? 16. And now what we're going to do is we're going to square root both sides to get rid of that squared. So I get plus or minus 4, and I get x plus 3. And now I'm going to subtract 3 from both sides. So I get negative 4 plus or minus 4 minus 3. So let's do those two answers. So 4 minus 3 is 1. Negative 4 minus 3 is negative 7. So my x-intercepts are 1 and negative 7. Bring that back down. All right, now that we've got all the information, let's make this bigger. Let's go ahead and plot kind of do like a little sketch, right? So, all right, so our vertex is at -3, 8, 1, 2, 3, 4, 5, 6, 7, 8. Axis symmetry is at -3. Our max is at 8. Okay, 0 and 3.5 is about right here. And again, I'm going to reflect that over. So how I reflect it is if you look at it, it has to be equal on both sides. Let me just kind of zoom in here a little bit. So if this is a distance of 3 here, I go 3 on the other side of my x-axis and then put a point. And then let's graph our two x-intercepts. So that was at +1 and -7. So 1, 2, 3, 4, 5, 6, 7. And these should be symmetric about your axis of symmetry. All right, remember this is a nice smooth curve, not a jagged line or a V-shaped graph, nothing like that. All right, now that is vertex form. That's it. Not anything, like I said. Probably the hardest part is just kind of making sure we get the y-intercept and the x-intercepts in there correctly. All right, let's go ahead and try vectored form. So each format of these equations has a benefit, okay? So like vertex form, the easiest thing to find is your vertex. In standard form, the easiest thing to find is your y-intercept. In factored form, the easiest thing to find are your factors, or in other words, your x-intercepts. So we use a couple other letters here. We're calling them P and Q. But again, what we're looking at here is once this is in factored form, all we have to do is solve both of those factors to solve for P and solve for Q and get your x-intercepts. So in fact, when I do factored form, that is where I start. So normally I start with finding the vertex, right? So we normally find the vertex first. But to be honest with you, in factored form, I'm going to start by finding the x-intercepts first. So the x-intercepts here would be, I'm going to solve this, and I'm going to get x equals P. So in other words, my x-intercepts are P, 0, and then if I did the same thing over here with Q, I would get Q, 0. So those are your x-intercepts. Okay, once I know the x-intercepts, now I'm going to find the vertex. So remember what I said on the last problem, that if you know your two x-intercepts, let's look at this one. This is 1, this is -7. Your y value, your x value of your vertex has to be halfway in between those two x-intercepts. So if you know the x-intercepts, all you have to do is average them to figure out the x value of your vertex. So in terms of like figuring out another formula, you don't really have to do that. All you're really doing is to get your x value of your vertex, and I'm going to write this kind of like this and see if that makes sense to you. I'm going to average P and Q. So it goes P plus Q, whatever those values are, and then divide by 2 is to get the average. And then your vertex would just be your K value for the Y value. And I'll show you how to find that. Min and max, that stays the same. So this is just going to be your K value. Y-intercept, we're going to do it the same way we did with vertex form, and that's plug 0 in for x. Oh, I forgot the axis of symmetry. So axis of symmetry is just x equals the x value of your vertex. And since the x value of my vertex is this little equation here, that's what I'm going to write. So the only thing I want to add here is once you know like your x value of your vertex, all you're going to do to get the y value is plug that x value into your equation and solve for y. So let me show you a couple examples with that, because I think that would be helpful. All right, number 1. Let's do k of x equals x minus 5, x minus 1. So you can tell this is in factored form, okay? So again, if I'm going to ask you to find all the information, I would start by finding your x-intercepts first, because that's going to be the easiest thing to find. So all you're doing is taking each of those factors, so x minus 5, set it equal to 0, and solve. Same thing with the x minus 1, set it equal to 0, and solve. So I get 5, 0, and 1, 0. Again, notice that I wrote them as points. Now that you know your x-intercepts, let's find your vertex. So the vertex is the average of your two x-intercepts. So if I had 5 and 1, and I average them, it would be 5 and 1 over 2. And then we're going to do our k value here. So what we're going to get here is that 6 divided by 2 is 3. So here's how you figure out that k value. So what you're going to do is you're going to take this 3 and you're going to plug it back into our equation. So for example, I'm going to do k of 3, which just means I'm plugging 3 in for x. And I'm going to plug 3 any place I see x. So 3 minus 5 and 3 minus 1. So what I'm doing here is getting the y value of my vertex. So I'm plugging in when x is 3, what is y? So this gives me negative 2, and this gives me 2. So when x is 3, this is negative 4. This is kind of like your input, your output. So what we just did there is we figured out the vertex by averaging our two x-intercepts. And then once I knew the x value, I plugged it back into our equation to get our y value. All right, let's do axis symmetry since that one's fairly easy. So it's just x equals 3 because it's our x value of our vertex. The a value in our equation is positive, which means there's going to be a minimum. And it's going to be at negative 4 since that's the y value of our vertex. And the last thing I need to find is our y-intercept. So that's plugging 0 in for x. So 0 minus 5, 0 minus 1. So I get negative 5 and negative 1, which gives me 5. So again, write it as a point. Let's go ahead and sketch a graph. So on this one, I'm going to go ahead and plot my x-intercept. So this is 1, 2, 3, 4, 5. I know that this is 1, this is 5. My vertex is at the point 3, negative 4. So 3, negative 4, that's my vertex. My y-intercept is 0, 5. So 1, 2, 3, 4, 5. Since this is our axis of symmetry, right down the middle, we can reflect that point. So it's 1, 2 spots over. It's 3 spots over from the distance from here to here is 3. So I'm going to do the distance from here to here is 3. So I get another point and then connect it with a smooth curve. All right, last but not least, let's do one last example with factored form. All right, y equals negative 4, and let's do x minus 3, x minus 1. All right, so like I mentioned, let's go ahead and start by finding our x-intercepts. So, I mean, if you can do this without, so this 4 out here makes no difference in our x-intercepts. This is still in factored form, so all you're doing is setting both of those equal to 0. So you can probably do that in your head, right? So you get 3 and you get 1. Your vertex, let's average our x-intercepts. So 3 plus 1 is 4. 4 divided by 2 is 2. And now let's plug this in. Let's plug 2 in for x. And solve for y, so we can figure out the y value. So this would give me negative 1, this would give me 1, so this gives me 4. My axis of symmetry would be x equals 2. This is opening down because of the negative, because of the reflection, so this would have a maximum at 4, because it's the y value. And then last, let's find our y-intercept. Plug 0 in for x. So y equals negative 4, 0 minus 3, 0 minus 1. So this would give me negative 12. All right. Again, we've got all this information. Let's see if we can graph this. Okay. So X-intercepts are 3 and 1. So here's 1, 2, 3. Our vertex is the point 2. And then 4. 1, 2, 3, 4. Remember, this is going to open down. Whoops, sorry. So this is going to open down. Our axis of symmetry is right down the middle, that vertical line. So this is our line of symmetry. Max at 4. Y-intercept is 0, negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 0, negative 12. And again, I like to reflect this point. So this is a distance of 2. So I'm going to go 2 spots over here, which would put me at 4. So there's my reflected point there. So now start with your vertex, sketch your parabola, and that's how it looks. All right, so that is factored form and vertex form. Both of those kind of rounds out your graphing part of this. So now you should be able to kind of find all of the information and sketch a graph regardless of the format of your equation. All right, that's it for now. We're going to practice this a lot more in class. If anything is confusing you, if you have any questions, please don't hesitate to ask during class. I'm sure everyone could benefit from hearing. All right, that's it for now.